Okay, so we're going to make a training video for exam 3, which is estimating primes. Caden, go ahead and share your screen. And anyway, we're going to use Caden's screen today so that Caden can drive. Yeah, hit the screen and then just hit share, and it'll do everything. So okay. It's got the right one. All right. Yeah, and this will work great for me too, because I don't have to breathe down your neck and I can just see what you're doing. So this is nice. But yeah, go ahead and open up your there we got the right button. All right, so let's do this. Let's do a block comment at the top of your code just to show everybody the question we're going to be working on. So to do that, it's three quotation marks, and then you can press enter and do another 3 quotation marks. Now go grab the code and put it in between those two, or the description, put it in between those two.
Just that.
Yeah, that's enough. Oh, there you got it. And you can word wrap that to make it pretty if you want.
That was fine.
Yeah, that'll work great. Okay. So Caden, do a Google search for me. And let's just start asking the question. Is there a Python is prime? Yeah, let's see if there's a function call. Oh, 6 best ways to check if a number is prime or not. There we go.
So functions, if else statements, math module, simple library, all those.
Yeah. So the first one is, all right, let's go and look at that code, 1.1 code. All right, so definition is prime, and you pass it in a number, and it says for n in range 2 to an integer, the square root of the number plus 1. What does that mean?
We're in range. Sure. Are the 2 asterisks, would that just be
Raised to the power of
0.5,
which is the square root. So Caden, basically here's a definition when you're checking prime numbers. One of the things you can get away with, like 9, is 9 a prime number? Well, you check 1. You don't check 1 because 9 and 1 are both factors of 9. That's a given. 2, well, 2 doesn't go in evenly, so that's not it. 3, yes, 3 goes in evenly. And then anything bigger than 3, no. And so one of the things they talked about in that chapter is you can stop checking at the square root of the number. So if you're going to check and see if like 25 is prime, you don't need to check 2 through 24. You just need to check 2 through 5. And so anyway, that's just a little trick to make the code run just a little bit faster. So what they're going to do is they're going to say, let n start with 2 and go up to the square root of the number plus 1. And if the number we passed in divided by the number that we were using in our for loop, our check number, if you will, if the remainder is equal to 0, return false. Otherwise, return true. So when they're checking 7, let's say for the sake of argument, square root of 7 is 2 point something. But because it's rounding it to an integer, so if you look at the code does int of number to the 0.5. Well, number to the 0.5 is going to be square root of 7. So open up a Google tab or something and let's get an exact number. So square root of 7. Yeah, 2.6. All right, go back to your code. Oh, no, that's it. I'm sorry. Yeah. So 2.6 is the square root of 7. But when we round that to an integer, what it does is it takes the point whatever and it clips it off. So int of the square root of 7 becomes 2. 2 plus 1 is 3. So that for loop, we're going to check 2 and we're going to check 3. So the first time, what's the remainder when you divide 7 by 2?
1.
Yeah. And what's the remainder when you divide 7 by 3?
1.
Yeah. And so are either one of those 0? So we'll end up returning true. So is 7 prime? Yeah, it is. How about 8? So same process. The square root of 8 is going to be like 2 point something, and it's going to be somewhere between 2.6 and 3, because the square root of 9 is 3, 8's less than 3, so the square root of 3, or square root of 8 is going to be less than 3. Cool, but it's bigger than 7, so it's going to be greater than 2.6. Either way, it's not going to be 3. So you take the square root of it and then convert it to an integer, it's going to be 2. 2 plus 1 is 3, and so we check. What's the remainder when you divide 8 by 2?
There is no remainder.
So you'd return false, because it says if there is no remainder, return false. Okay, so essentially that's how you can do it. But what I would argue is there's going to be some inefficiencies in that code. So we're not going to worry about that right now. Let's go ahead and scroll down and see what else they have for options.
That looks pretty similar to the first code.
Yeah.
Is all this 1 point just added on to 1.1?
Yeah, I don't know what they're. Yeah, let's keep going and see if.
Yeah, method 2.
There we go. Nope, let's keep going. Import math. Square root of x? No, come on, kids, you can do better than that. SimPy is prime. There we go. Import SimPy, print SimPy is prime 90. That's what we want right there. That's the good stuff. All right. Fundamentally, what is it going to do differently?
It's just is it able to calculate bigger numbers quicker?
Well, you know what? We can do this one of two ways. There's part of me, Caden, the part of me that teaches algorithms that says we need to do it both ways and time it and see which one's faster. What does the question actually ask? Alt tab is your friend.
Alt tab.
Hold down Alt, press tab once. Press it, tab again. Now release. There you go.
That's pretty handy.
So the number of primes, write a program to count how many primes are less than big numbers, and then fit a curve to estimate the number of primes. Okay, so do we need to know which one's faster? No. I'm going to tell you that in general, using somebody else's code is almost always better. So let's see if we can write a code that does this. All right, so Caden, I'm going to design this one backwards. This one is there's lots of different ways that we can design this. The first thing I'd like you to do, let's just create a for loop. And what I want the for loop to do is to multiply a number every time through by 10 until it gets to 100 million, and just print the number off. Does that make sense? So I'm going to have a for loop, and then I'm going to say index for index in range. How many zeros is that? 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to do in range 1, comma, I'm just going to guess 9. And then I'm going to say maybe something like that. So I scribbled something down on a sheet of paper that's horribly stupid code, but Caden, let's see if we can get that running right quick.
Include those two.
Yes. Yeah.
What is that, a asterisk for?
Yeah, times, yeah. So shift and 8.
Okay.
I think you have to do the, I forgot the, there you go. Run that puppy. I think it's F5. All right, it's not pretty, but is that 100? Is that 100 million for the last number?
Yes.
Sweet. Only
Okay,
took
so
it only took me like 3 guesses on how to get that code right. Not bad for on Friday. Okay. All right, Caden. So that's part of it. Let's refactor that right quick. Double click the word number. And right click it, or no, just do Control R. All right. So instead of number, go down to where it says replace with at the very bottom. Let's replace that with the word range, or range limit. And I think hit find next, and then so you don't want to change it in the paragraph. So if you can go to the next one, and then you should be able to do, I think if you click that that check mark where your mouse is, yeah, click that. That's fine. Do Control Z. Okay. Can you make that bottom part a little bit bigger and see if we've got the option to do anything and like go to the next one? Like skip it. All right. You know what? Is it range underscore limit?
It's just right now. I put a space.
All right, make it an underscore because it's going to be a variable name. All right, double click that word and copy it. And then up in your code, line 5, 6, and 9, just double click those and replace it. There you go. Oh, something weird happened on 8. I think you missed an underscore.
Oh. Yeah, what happened?
I don't know. Just drop the underscore back in there and it'll be okay. Should be okay, I think.
Like here?
Yeah.
That's weird.
Weird things do happen.
It's a plus sign.
Try to make an adjustment here. There. Now I can see better. All right. Cool. So you know you've got your range limit doing what you want it to do now, right? So it says estimate the number of primes less than X. Write a program to count how many primes are less than 10, 100. Okay. So after line 9, here's what I'm thinking we can do. We can do something like we can set number of primes equals 0, and we'll say for check number in range and we'll do 1 comma and then it's going to end with a parentheses and a colon, and then we say, oh, in here we need to do that import SymPy, and then we'll do if, and then I think it's just SymPy dot is prime check number, and we'll say we'll just say print.
Oh, it's not what I not it's prime.
No, you're inside that last parenthesis. You need to go outside of it.
Oh,
One more. Yeah, it's an okay spot for, you need one more parenthesis there because we've got the
Oh,
if statement parenthesis and then the function call. Now you can drop your colon.
okay.
All right. Now you want to go one more level back. There you go.
Try running that.
Yeah, but why is it not happy on line 13?
Or check number and range.
Ah, range int should be range limit.
Oh, all right. That's my mistake. Is it the same as the other range limits?
Yeah.
Underscore.
Yeah, no, that's all right. Caden, that's a good question. I want you to think that through for yourself and talk me through if you believe that or not.
If I believe it's the same range limit as the others. Guess the reason I thought it was possible that it wouldn't be is because it was in parentheses. So
Okay. Why is it not happy about line 15? What's that red dot on the left?
Undefined name, number of prime.
Yeah, you're missing an S.
Oh, primes.
All right. All right, let's save that and run that.
As a control S to save.
Yep, control S to save and then control, or F, I think it's just control F5 to run it.
F5.
All right.
So just inputting the number and it should work. Like 90.
No, it's not happy about something. It says debug, WDIR, user Caden programming, estimate number of primes, debug file. Do you see anything that I'm missing? All right.
There's no red dots even.
Go back to that code, the one example on the internet. Is it so SYMPY? That's correct, right?
Yes.
All right. Does Anaconda recognize? Go back to the error. Let's see if what the error is. Hit the play triangle, the big play triangle.
Like this one up here.
Yeah, let's just run it that way. Cool. Now, here's my problem. I don't like the way you're printing your print stuff because I get confused. So let's take time and let's comment out line 10 and line 16.
Okay. That's the 3.
No, you can just do shift and the number 3.
Okay. And what other line?
Line 16. No? Well, I mean, because it won't print anything off.
Oh, yeah.
I think you put your, all right, let's go to the end of line 16, press enter, and let's make a new print statement. So let's do print, open parentheses, and let's try something like this. So what I would like to see is a print statement that's a little more like you would naturally say this. So I would say there are number of primes, and number of primes is actually a variable, less than, and then and we can drop a period at the end because it's a statement, and then it's just in a quotation like that to end. So that can all be on one line. I just scribble like a second grader. So My one complaint I have right now is that when we're doing these print statements, it doesn't recognize that that should be a variable. I don't like that. I haven't quite figured out how to deal with that yet. Okay, let's, why is it not happy? Indentation errors. Okay, so what I want you to do is, I think on line 16, let's delete that comment that you made. Now, keep hitting delete till it goes up to after the next line. Now press enter. hit backspace. And backspace one more time. Okay. Now do the same thing on line 17. Oh, Control Z. Then just press return. Or yeah, enter, I guess. There we go. All right, run that puppy.
You want to block this 16 out again?
Yeah, that's a good idea. So it's very important when you're
Oh,
playing with these codes that, like on line 10, it looks like you did the same thing. Now, you also want to be very careful not to use the space bar when you see problems like that, and to only use your tab key, because Python uses tabs to know where it's supposed to go back and forth.
okay.
All right, let's run that puppy and see what it looks like.
4 less than 10. Definitely looks nicer than the first one.
Okay, so we've got 1, 10, 100. There's 1,000, 10,000, 100,000, a million. Now it's taken a little bit longer to get 10 million, and it'll take a lot longer to get 100 million, because every time it does, it starts over at 0. So it kind of, the time that it takes to do this stuff, it grows exponentially. Okay. So what's the problem definition? And we'll think about the next byte. Fit a curve to your data and estimate the number of primes less than x, where x is a positive integer. Cool. All right, here's what I want to do. Let's go back to that print statement right quick. Actually, you know what? I'm extremely lazy. Let's go ahead and let's change the print statement. Do it this way. Just comment line 17 out for now. Do on the next line, just do that print statement.
I always forget where those little squiggly things are.
I know it takes practice. You don't use them very often. Okay, run that puppy. Okay, so now let's grab. Oh, I see. Go up to the top, and you'll have to hit the which one is the stop button?
This, no.
Can you go in there and hit Control C? Sometimes it'll let you do that. Yep. Okay, now hit the green button. All right, highlight the numbers that you have there. Copy them, open up an Excel spreadsheet. Paste that data in. Control Z. No, wait. Hit see where it says the down arrow next to the CTRL. Use text import wizard. No, let's see. All right. try fixed width, or wait, yeah, fixed. Oh, yeah, click on, just try some different option because it was not right. All right, actually hit cancel and then delete that. All right. Oh, do a Google search for Python print statement tab escape character.
Escape character.
Mhm.
That's not household character.
It's probably close enough. Yeah, the top, the blue print tab in Python. \T. All right, go back. I was wrong. Go back to your code. See that comma that I had? Delete the comma, make it a \T.
Right here.
No, not that the comma, the after range
comma,
limit.
yeah.
Yep.
Okay.
I was trying to do a comma separated value because I thought of CSVs. And I was trying to be fancy.
\T.
Yep, \T for tab. All right. Go down in your code. Yeah, down here, do Control C because it's not done yet. Actually, change that 8 to a 5 or that 9 to a 5. Okay, now run it. Yeah, not my bad. And it's done. Okay, highlight that, copy it. Yay. All right, so let's right click that and do insert table. No, cancel. Maybe it's data. Yeah, highlight all of it. Okay, go like this. I think on the top ribbon, maybe it's like data.
Oh.
No. Insert. Let's try insert. And then plots table. I think there's a, yeah, charts. There you go. And let's do a scatter plot. Okay, can you hit the plus? And let's do a trend line maybe. And then hit the arrow over after trim line. More options. Okay, so with only 4 points, maybe it's linear. Linear looks okay. All right, so let's try a linear fit and let's do display equation on chart.
So display a linear fit.
Yeah, it's already linear.
Oh, okay.
All right. Okay, so what number does it give us?
0.1212.
So it says y equals 0.1212 x
plus
19.97. Cool. All right, and so it stops at 10,000. What we need to do is, can you, all right, so you just take 0.1212 times 100,000. So
12 times 100.
So that'll be 12,000, 1,220 plus 20. So it's going to be about 12,140. All right, so that's our prediction for 100,000. Caden, go back to your spider environment. So for 100,000, how many did we have?
Not.
So let's see, 10,000, that's 100,000. We had about, yeah, that's not too far off. Okay, go back to that 5 and make it a 7. And now run that. Okay, copy those additional 2 columns or the additional 2, copy it and go paste that in your Excel spreadsheet. Okay.
Just copied all of them again.
No. All right. Control Z. Delete the ones you have. Delete the chart. Just delete. Yep. There you go.
Where is it at? There it is.
That's okay.
Did I press delete?
That's fine. Just hit OK. Yeah. All right. Delete the chart. And just there you got it. Hit escape. Press the delete key.
Backspace. Oh, yeah.
All right. Now go get your data. And all right, we're going to do 2 things. Change the 7 to an 8 and start it running.
Before I grab my data.
Yeah. And run it. Okay, now the cell 5, grab the one that finished for 5. No, next one down.
Oh,
There you go. Copy that. Go back. And we'll repeat the exercise. Yep, it all worked.
so it's all good.
Yeah, that tab worked. Now do insert a chart.
We do linear on that?
Yeah, it's already linear.
Okay.
Yeah, oh no, go ahead and select linear. Hi, Sherry. All right. Oh, and on the chart options, text options, maybe. Oh, all right. I think you'll have to close that on the, you'll have to close this on the side and then do more options here. And then display equation on chart. So it's a little bit smaller, but now we've got a different number. And so again, you can use that to make a prediction for what the next one is going to be. So what is the, for row 7 on your data, what is that? What is that going to be? What's the next number?
What is this one? 10 million?
Well, I don't know.
Wait.
My eyes aren't that good.
That's 1 million. So next one would be 10 million.
All right. So what's 10 million times 0.0782? Go ahead and use a, what you can do is on line 7, punch in 10 million. So I would just do equals upside up arrow times 10.
Equals 0 times 10.
Oh, no, hit the backspace. You know, that's a chevron. One more time, hit the actual up arrow on your keyboard.
Oh,
Now times 10.
that's cool.
Enter. Now put the cursor next to it and do equals left arrow times 0.0782 plus 439.42. Enter. So it's estimating you should find almost 800,000 primes. So let's go see what your code generated.
66.
Okay. All right. So Caden, do you feel like you've got a way that you can do this now? Does this is this starting to make more sense?
It's making more sense, but it's still pretty.
So essentially what we're doing is we're just taking and we're plotting our data. And then we're using Microsoft Excel tool to fit a line to the data. Now, one of the other questions you could ask, if you had more data, would the curve change?
I'd assume maybe.
Well, let's take a look at this and find a resolution. Change your step size from 10 to 2. And change your range from 1. Okay, so 9, that was getting up to 9 million. Let's change it to 20. No. On line 8, change the 8 to a 20.
Oh,
and then run that. Grab that data. Let's go back. Now leave that data alone. Just go down a couple of rows. All right, paste it in. All right. So 1024, we've got 172, 1,000, we've got 168. So that means between 1000 and 1024, there's 4 prime numbers. All right, plot that set of data. So just go up to insert and yeah. Now, I assume that if you move that, yeah, do the add and the, yep, now I can, all the fun things.
okay. Didn't change it too much, but it looks like it changed it a little bit.
Yeah. Well, and also your value, your X scale is different a little bit, but here's the basic idea. Actually, there's a lot of good ideas that come out of this discussion. One of the things is as you have a larger range that you're looking for, the likelihood of finding another prime number goes up, and it seems to go up relatively linearly, which is a convenient thing. The next thing to consider, actually, I think it's actually supposed to be more of a logarithmic number, and what I mean by that is, if you're looking at your data, notice how your first line, your first dot and your last dot are actually, so the data is kind of doing a little bit of a horseshoe facing down just a little bit, and so we're getting a line that's just going kind of across it. And so tell it to display your R² values on the chart. So that's just a checkbox over here.
Oh, yeah.
Okay, now what I want you to do is highlight the rows 10 through 28 again. Let's insert another chart.
Another scatter.
Yep. And on that one, add another trend line. And yep, trend line. And then more options. And for this one, let's do logarithmic and display the equation and the R values. Okay, so that one was obviously worse. Now do the same thing again and try an exponential.
Do I need to click off this one at all? Or you think
I don't actually know.
looks like I did.
But the idea, what we're doing right now is we're just asking the question.
Yeah, which one did you want? this one?
Let's try a polynomial. Okay, so here's my question. What gives us our best R value? So 1 is perfect, a perfect fit, and 0 is bad. So 9998 is pretty good, whereas 9982 is not quite as good, but it's not bad. So what I would say is, I would probably, if I had to do an estimate, I would probably use the one with the better R value because it's a better model.
So that was the
polynomial, yeah. More complicated model, better fit of the data. All right. So the idea behind all this, Caden, is you have the ability to model data. You have the ability to change how you're modeling the data. And then based off of that, one of the good questions with modeling is, can you predict the next one? And the fun thing is, mathematicians have more exact models on how to predict where they think the next prime number should be. And the reason that's important is we're getting to the point when we're looking for prime numbers that it takes a long time to just check one number because the numbers are so big. All right, Caden, you have any questions, any comments, any thoughts?
I don't believe so.
The code on this one was more straightforward, but the implications for its use for things like security protocols and cryptography, they're pretty cool. Awesome. Well, hey, I am going to go ahead and kill our meeting off. Caden, thanks for your good work and take care. Bye.